I want to talk about understanding the core through several simple examples. Here's the simplest type of example, and we normally won't be considering these sorts of things, but let's say we have just a two-player game. The set of players is just player one and player two. And in this example, let's just say, well, we always have the value of the empty set is 0. Let's just say that the singleton set 1, player 1 by himself, can get 3. The value for player 2 is 2. And the value of the coalition of 1 and 2 together is 7. What must any imputation satisfy? Well, to be an imputation, we need x1 plus x2 to be the value of the grand coalition, which is 7. So we must have x1 plus x2 equals 7 to be group rational. In order to be individually rational, we need x1 to be at least 3, and we need x2 to be at least 2. Any payoff vector, x1, x2, that satisfies these conditions will be an imputation. It will be both group rational and individually rational. So for example, you could have the payoff vector 3, 4. You could have anything bigger than 3 combined with something less than 4. I'll just give you examples using integers, but these don't have to be integers. So you could have 4, 3, for example. You could have 5, 2, and remember, you could have things in between. You could have 3.5, which is 7 halves, and 3.5, 7 halves. You could have things like this. As long as you have a sum that's equal to 7, the first coordinate being bigger than 3, the second coordinate being bigger than or equal to 2, you'll have an imputation. So basically, it's every payoff vector that's somewhere between this 3, 4 and this 5, 2. Now, those are all the imputations. What can we say about the core? Well, the claim is here, if you just have a two-player game like this, not just the example that we showed, but any two-player game, all imputations are in the core. Why? Because there are no other coalitions to worry about. An imputation is stable under coalitions of size 1, because they have to be individually rational, and coalitions of maximum size, meaning the grand coalition. And for a two-player game, every coalition is either the grand coalition or a coalition of size 1. So you can't really have any other coalitions to cause instability, so it's kind of a triviality. The core is not an interesting concept when we have just a two-player game, and we're not really going to be talking about two-player games in coalitional form, in part for that reason. Let's look at a different example now where we have a three-player game. I've described precisely the characteristic function for this three-player game. Remember, in a three-player game, there are 8 subsets of players, 8 possible coalitions. That includes the empty set. That includes the grand coalition here, and includes all the others. And I've listed just possible values for the characteristic function for each possible coalition. I've listed what they are. Our question is, what do imputations look like? Well, if we have a payoff vector x1, x2, x3, to be an imputation, we need the sum of those payoffs to be 9. That's the value of the grand coalition. So we need to get 9 total. And to be individually rational, we need x1, the first entry, to be at least 1. That's because the value of this player 1 by himself is just 1. We need x2 to be at least 1 because the value of player 2 by herself is just 1. And we need x3 similarly to be greater than or equal to 2. Any triple x1, x2, 3 that satisfies this equality and these 3 inequalities will be an imputation. Now it's actually a meaningful question. What does the core look like? Because there are other coalitions, namely these coalitions, which still might cause instability. So it can be useful sometimes to graph all the imputations and see what the conditions look like that say the imputation is stable or unstable relative to these other coalitions. And we can start that by graphing x1 plus x2 plus x3 equals 9. If I just draw a three-dimensional coordinate system, think of this as x1, x2, and x3, x1 plus x2 plus x3 equals 9 is a plane it clearly goes through these points. This would be 9, 0, 0. This would be 0, 9, 0. And this would be 0, 0, 9. So we want the plane that goes through those 3 points. I'm just going to draw this triangle here. So imagine the plane that contains that triangle. That would consist of all of the points that are group rational. But then we have to ask, what do these inequalities look like when placed on this figure? Well, it can get very awkward drawing everything here in three-dimensional space, but let's just kind of get started and see what it looks like. If x1 is greater than or equal to 1, what does that look like? Well, let's look what happens when x1 equals 1. When x1 equals 1, we would be at a point here. We could look at points, say, up here and down here where x1 equals 1 and ask what those points would be. We know the sum of the coordinates has to be 9, so this would be the point 1, 0, 8. And this would be the point. I won't write the coordinates here. In fact, let's not even bother to have the coordinates there. If we want x1 greater than or equal to 1, let's say we also want, as we do, x2 greater than or equal to 1 and x3 greater than or equal to 2, what points along here would meet those conditions? Well, in order to have x1 greater than or equal to 1 and x2 greater than or equal to 1, we could look at this point, which corresponds to the point 117. Let's write the point 117 up here. If we go down 1 over 1 and up here, here's the point 117. So we're just making these two equalities, and we're looking at this inequality. We're ignoring this for now. We're certainly well over 2 for x3. Let's consider if we have two of the other ones equalities, x2 equals 1 and x3 equals 1. If x2 equals 1 and x3 equals 1, I'm sorry, x3 should equal 2. So let's look at x2 equals 1 and x3 equals 2. We could look at the point that's way down here. x1 would end up being 6. So we'd have 6, 1, 2. That would be a point over here. 6, 1, 2. That makes these two equalities, and this one is left as an inequality. And then let's look at the last possibility, where the first and the third are equalities. x1 is 1, x3 is 2. x1 is 1, x3 is 2. So we go up here, and x2 would then be 5. So we have the point, I'm sorry, 6. We have the point way over here. That's 1, 6, 2. In order to be group rational, we have to be on this plane. In order to be individually rational, we have to look where's the points where x1 is greater than or equal to 1. Well, on that plane, we connect these, and we want all points down and to the left of that line. If we look where x2 equals 1, we have connect these 2 points, and we want to be down and to the right of that line on this plane. And when we look at x3 equals 2, we want to be above that line. Now, it's really hard to keep drawing pictures here in three-dimensional space on this kind of slanted plane. So what we're going to do is take these 3 points here, the point 117, the point 612, and the point 162. We're not going to want to be outside of that triangle anyway, so we'll just draw that triangle. And this is what the book calls barycentric coordinates. We're talking about coordinates all located on this plane, x1 plus x2 plus x3 equals 9. That's on this slanted plane. We have these points. These are the actual coordinates in the three-dimensional space, but you have to imagine this plane is there, slanted on the plane that contains that original triangle. All of the imputations are points that are in this triangle because they'll meet all of these conditions. Let's look at a particular coalition. Let's look at the coalition 1, 2. Well, we're told that the value of that coalition by itself is 3. And you'll see, for example, that this point 117, this is an imputation, has a total amount for player 1 and player 2 together of only 2. That's less than the value. So that one is not going to be in the core because that point right here at the very top is unstable. I'm sorry, this payoff vector is unstable through this coalition. How can we find which payoff vectors are stable through the coalition? Well, let's try to see what happens when x1 plus x2 equals 3. That means the payoff to player 1 and player 2 is equal to 3. That's equal to the value for that coalition, 1 and 2. Here you see x1, at this point, x1 plus x2 is just 2. Way down at the bottom here, x1 plus x2 is 7. So if we take a line parallel to this bottom line, we want where x1 plus x2 equals 3, that's only a little bit bigger than the 2, but well less than 7, we'll actually get a line like this. All right is x1 plus x2 equals 3. Any point here in the allowable imputations that's below this line will have x1 plus x2 bigger than 3. So that means that things that are above this line have x1 plus x2 less than 3. These points that I've just shaded here are imputations which are unstable through this coalition 1 and 2. We can do the same thing for these other coalitions. Let's look at the coalition 1 and 3, and I'll just remind us here the value of that coalition is 4. So let's try to plot x1 plus x3 equals 4. And now we can see x1, let's see, for x1 and x3, x2. Here in the lower right, we have x1 plus x3 equals 3. Everywhere on this line up here, x1 plus x3 is equal to 8. So x1 plus x3 equals 4 will be a line parallel to this upper left edge of the triangle. This x1 plus x3 equals 4. And again, to have x1 plus x3 bigger than 4, we'll want to be above that line, because points here, the 6 plus the 2, or the 1 plus 7 is where x1 plus x3 equals 8. Points down here will have x1 plus x3 less than 4. So here, imputations in this region will be unstable through this coalition, the coalition of 1 and 3. And finally, if we look at the last coalition that we have to deal with, the value for the coalition 2 and 3 is also 4. So if we look at x2 plus x3 equals 4, and we draw that line, notice that x2 plus x3 is only 3 way down here in this corner, but x2 plus x3 is 8 up here along this line at both of these points and at every point in between. We can look at a line like this, parallel to this upper right edge. I say parallel because this upper right edge is where x2 plus x3 is a constant, just a bigger constant. Here we have x2 plus x3 equals 4. That's on this line. We'll find this region where x2 plus x3 is less than 4 is a region that consists of imputations which are unstable through the coalition 1 and 3. So where does that leave the core? That leaves the core is this region here, where all of these conditions are satisfied. We have imputations, and we have x1 plus x2 greater than or equal to 3, if we include the boundary, x1 plus x3 greater than or equal to 4, and x2 plus x3 greater than or equal to 4. We'll meet all of these inequalities, those and these, as well as that equality. That's all in just this region here in the middle.